Just as a reminder, as you do your identity proofs, you do have to declare the side you're going to work on. It is best to choose the side that has the most terms. So I would choose, in this case, the left-hand side. So I do need to declare it, and then I'm going to rewrite it just as it is. Secant of theta. Please don't drop your angles. 1 plus the tangent squared theta. What I mean by that is please don't write this as the secant 1 plus the tangent, because that means nothing to me. Don't drop your angles out. So please do not drop out your angles. We didn't do this one? I thought we did this one. Okay, so when I see tangent squared, I immediately think, do I have the Pythagorean identity? And in the denominator I have tangent squared, and this actually is a Pythagorean identity. 1 plus tangent squared theta is equal to secant squared theta. So what I really have is the secant of theta over the secant squared of theta. I'll stop. Does anyone have any questions so far? Okay. Now, the numerator and the denominator are the same thing with the powers of difference of 1. So I know that these will cancel down, and this cancels into 1 over the secant of theta, which is how we define cosine. And so I have found my right-hand side. Okay? How was that? Is there any questions on that one?
That's cosine?
1 over the secant is cosine, yes. Please become very familiar with that formula sheet, because I give that to you on the test. You don't get to bring your own in. It's actually a laminated formula sheet. And you want to know where everything is before the test. Otherwise, you're going to spend way too much time trying to figure out where everything is on that formula sheet. Yes, CJ.
On the formula sheet, it says tan squared is cosine. Is it the secant squared theta?
Okay. Now, the question he asked was the tangent squared is sine squared over cosine squared, but I'm not doing that. What I see is 1 plus tangent, so I think it might be, my initial reaction would be, I think it's probably one of the Pythagorean identities. So even if I didn't have the full formula sheet, what I know is that this is going to be true. The cosine squared of theta plus the sine squared of theta is equal to 1 all day long. Now the way that we define tangent is sine over cosine. So if I took this thing and divided each term by the cosine squared theta, I'd get one of the equivalent Pythagorean identities, which is 1 plus the tangent squared theta is equal to the secant squared theta. So even if I didn't have that formula sheet in front of me, and as long as I knew the original one, which is the cosine squared plus sine squared, then I can just do a switch out. Does that answer your question?
Yeah.
Okay.
Can I ask a quick question?
Yes.
So is 1 over secant is cosine, you said?
Yes, that's how we define cosine. So what we know is, the other thing is that if I tell you that the cosine of theta is equal to 1 over the secant of theta, then the secant of theta must be 1 over the cosine theta, because they are reciprocals of each other. Those hold true all day long. So again, on the formula sheet, if I only give you on the formula sheet this one, then we know that we can get to the other one because of the fact that they are reciprocals of each other. All right? All right, I'm going to make this smaller. If you guys could do these next 3, please. Use the right-hand side. So we're going to take the right-hand side on this. Right-hand side. I'm going to rewrite the right-hand side as 1 plus the cosecant of theta, 1 minus the cosecant of theta. This is equal to, what is the relationship between cosecant and sine? They are reciprocal, so write this as 1 over the sine of theta, 1 minus 1 over the sine of theta. We have something called a complex fraction. We have a fraction within a fraction. Option A is you make a single fraction in the numerator, a single fraction in the denominator, and then you take the numerator fraction, multiply by the reciprocal of the denominator fraction, and you do a whole bunch of work. Not a fan. So instead, I'm going to multiply every single term by the common denominator of all of those fractions, which happens to be sine theta. When I multiply each term and distribute that sine theta through, I'm going to get the sine theta plus 1, sine theta minus 1, which is the left-hand side. Had you chose the left-hand side to begin with, you would have done the exact same algorithm as what I just did. Questions on that one? Yes?
So instead of doing the multiply by your common denominator, I
That's fine.
did a little more work, but I got minus 1 and plus 1 on the bottom. But can I show that exact same process I just did? So I just showed how to, in the very beginning, it's plus 1 minus 1. I ended up flipped. I had to show that exact same process again. I can show that I can flip it back.
Okay, so walk me through what you did.
So everything's the same until we multiply there. Then
Okay, so you chose the right-hand side.
I chose the left-hand side.
You chose the left-hand side? That's fine. It'll get you the same thing. So you have the sine theta plus 1, the sine theta minus 1. You wrote this as 1 over the cosecant of theta plus 1, 1 over the cosecant of theta minus 1, right? A numerator fraction, so to make the numerator the exact same fraction, you have to multiply it by 1 over 1 by cosecant. And so you should have had is 1 plus the cosecant of theta over the cosecant of theta over. Did you get that far? Okay, let's back step a little bit, make sure that we're all on the same page then. If you were going to do a single fraction in the numerator and a single fraction in the denominator, we have 1 over the cosecant of theta plus 1 over 1 over. Similarly, in the bottom, cosecant CSC theta minus 1 over 1. Now, to have a single fraction in the numerator, you do need to multiply by the cosecant theta here and the cosecant theta here. That'll take care of your numerator fraction all having the same common denominator. The cosecant theta, the cosecant theta. So what you end up with is 1 over the cosecant theta plus cosecant theta over cosecant theta over 1 over the cosecant theta minus the cosecant theta over the cosecant theta. See why I'm not a fan of this? We keep moving. We get 1 plus the cosecant theta over the cosecant theta divided by 1 minus the cosecant theta over the cosecant theta. Still not a fan. So I end up with 1 plus the cosecant theta over the cosecant theta multiplied by the cosecant theta, 1 minus the cosecant theta. Still not a fan of this. And I finally end up with 1 plus the cosecant theta, 1 minus the cosecant theta. Do you see why I multiply everything by the common denominator? Because I love myself. Same way, you get the same answer either way. Are we all still working on G, or are we done with G? We're done with G? Okay, so let's go ahead and work through G. Which side do you all want to pick? Left-hand side. All right, now remember from our Pythagorean identities, in fact, we just did it right up, where is it? Here. you see this? We just did this earlier. So what I have, if I take this identity right here and I solve for tangent squared, I'm going to get this. So if I get that, that means down here, what can I do with that denominator? So what can I do with my powers? Cancel out and reduce. How do we define tangent theta in terms of cotangent? Right hand side. Okay, how was that one? There's going to be a couple of these on the test, and I'm hoping that they're going to be easy points for you, is what I'm hoping.
Can you go over the first part of that again? How we got the tangent squared?
Okay, so I go back up. The question was, how did I get the tangent squared? Now remember when we started out with the fact that I had ended up with 1 plus the tangent squared theta is equal to the secant squared theta. So this is pattern recognition. I have secant squared theta and I have minus 1 in the denominator. So if I take this particular one right here and solve for tangent squared, I get that pattern that I want, which is secant squared theta minus 1. So all I've done is I've taken this thing I've boxed in green and solved for tangent squared theta. And that's how I was able to do that replacement there. There is a lot of algebra going on in here. And if you are the god or goddess of algebra, you're going to frickin' love this stuff. If you are not the god or goddess of algebra, it will be delicious for you. It'll be the most delicious thing you've done all year long. All right, how about H? We still working on H? All right. As you were still working on H, I'm going to bring this up so you can do H, I, and J. So if you have done H and you're waiting, let's talk briefly about H. Now, with H, what I see is a mix of sine and cosine, secant, cosecant, cotangent. The left-hand side has cosine, but the right-hand side does not. That leads me to want to use the right-hand side and print everything in terms of sine and cosine. So I'm going to declare the right-hand side cosecant squared theta plus the cosecant theta cotangent theta. And I'm going to turn everything in terms of sine and cosine because the left-hand side has cosine. So the relationship between cosecant and sine is there are reciprocals, so I can replace cosecant squared with 1 over sine squared theta. Make sure you put the squared between the n and the angle. And then plus, I'm going to replace cosecant with sine, so 1 over the sine of theta. I'm going to replace cotangent with its sine cosine equivalent, so that's going to be the cosine of theta over the sine of theta. Is there any questions so far? Okay, cool. In the denominator, I'm going to end up with sine squared theta plus cosine theta over sine theta, sine squared theta. Do you all agree to that? My denominator is the same, so I can write it over itself. So I can write it all over the sine squared. So 1 plus the cosine theta, sine squared theta. I need everything in terms of cosine because my left-hand side screams cosine. So using my Pythagorean identity, if I have the sine squared theta plus the cosine squared theta is equal to 1, that means the sine squared theta is equal to 1 minus the cosine squared theta. Do you all agree to that? Okay, Fred, let me back up. Do you see all of that where it was?
Yeah.
Okay. So I'm going to replace the denominator with 1 minus cosine squared theta. But this has the form of a squared minus b squared, the difference of squares. So this has the form of a minus b, a plus b. So I can write 1 minus cosine squared theta as 1 minus the cosine theta, 1 plus the cosine theta. Do you all agree to that? So in the numerator, I have 1 plus the cosine theta, and the denominator, I'm going to replace it with 1 minus the cosine theta, 1 plus the cosine theta. What happens to my 1 plus the cosine theta? They cancel themselves out. So in my numerator, I end up with 1. In my denominator, I have 1 minus the cosine theta. So I have reached my left-hand side. How was that? In all of its glory. Is there any questions on how I did any of this? Okay, are you all working on I still? Is there anyone that is finished with I? Got a couple finished with I? Okay, I'll give you another couple of minutes and then I'm going to just go through the answers. Tomorrow we are going to get the law of sines in. There's no way I'm going to get the law of cosines in on the same day, so we'll all have our test on Monday. Sorry, the test is Monday. It is Monday. It's just one of those things. We're going to have the test on Monday, which I know I try not to give you a test on Monday because it kind of blows your weekend, but some people are really excited about having the test on Monday, so for those who are excited, you're welcome. Those who are not, I'm sorry. So let's go ahead and work on I and J, finish working on those, and I'm going to give you the answers in a couple of minutes. On I, I'm going to choose the left-hand side because it has the most terms. So left-hand side, cosine theta, 1 minus the tangent theta, plus the sine theta, 1 minus the cotangent theta. I'm going to turn all my tangents and cotangents in terms of sine and cosine. So the cosine of theta, 1 minus the sine theta over the cosine theta, plus the sine theta, 1 minus the cosine theta over the sine theta. I gave myself some room there because I don't like fractions and fractions, and I don't like to make a fraction over a fraction. So what I'm going to do is multiply by the lowest common denominator. The first fraction, the lowest common denominator, is cosine. So I'm going to multiply the numerator and denominator by cosine and distribute through. The second fraction, the lowest common denominator, is sine. So I'm going to multiply by sine theta and distribute through. My first fraction becomes the cosine squared theta. In my denominator, I have the cosine of theta minus the sine of theta. My second grouping, I'm going to get plus the sine of theta in the numerator, and in the denominator, I'm going to get the sine of theta minus the cosine of theta.
What do you have written inside the red parentheses at the bottom?
What are you asking me about?
Of the second set of red parentheses, what's in the denominator there?
That's cosine over sine. That's some really bad handwriting. Okay, and that should be sine squared. All right. In the denominator, I have this rule that says if I have a minus b, I can pull out a negative and make it a negative a plus b, which means I can write this as a negative b minus a. Do you all agree to that? Okay. So in the numerator, I'm going to have the cosine of theta, cosine squared of theta, cosine theta minus the sine theta. On the next one, I'm going to pull out a negative so that plus becomes a minus, and then it becomes sine squared theta over the cosine of theta minus the sine of theta. Same common denominator, so I'm going to put them over that denominator. Have the cosine squared of theta minus the sine squared of theta all over the cosine theta minus the sine theta. Numerator is a difference of squares, so I'm going to factor it as such. So this is going to be the cosine of theta minus the sine theta, multiplied by the cosine of theta plus the sine theta, all over the cosine of theta minus the sine theta. Those cancel. I end up with the cosine of theta plus the sine theta. Is that what I needed to have? Is that it? Did I get my other side? Yep, there it is. Right-hand side. Turbo smoking fast. I know I'm not answering questions, and I apologize, but I do need to get through this. On this one, I'm going to choose the left-hand side. So I have the sine of theta, the tangent of theta, plus the cotangent of theta. So I have the sine of theta. I'm going to turn tangent into sine over cosine. I'm going to turn cotangent into the cosine over sine. I'm going to distribute through my sine. So I have the sine theta, sine squared theta, over the cosine of theta, plus the cosine of theta, and that's it. I need to have the same common denominator because this is currently over 1, so I'm going to multiply this by cosine theta and cosine theta. I have the sine squared of theta over the cosine of theta, plus the cosine squared of theta over the cosine of theta. My denominators are the same, so I'm going to put them over themselves. So I have the sine squared of theta plus the cosine squared of theta all over the cosine of theta. Numerator is equal to 1. Denominator is cosine theta, which is equal to the secant of theta, which is my right-hand side. Smoking turbo fast. Please watch the video. I know I went fast. We're going to talk a little bit about the domain and range of these things tomorrow when we start doing the laws of sines and cosines. So tomorrow we pick up 11.2. Have a great day.